Bloat on our websites. Our mission today, if you choose to accept it, is to achieve the fastest possible navigations on the web. So I'm going to tell you how that's possible. My name's Ryan Townsend. I'm a principal product manager at Cloudflare. I've spent over a decade focusing on web performance. Thank you. And I joined Cloudflare just back in March, a couple of months ago, to take over responsibility for our real user monitoring tool. This is something that you can use completely for free, whether or not you're even using Cloudflare as your content delivery network. And I mention this not as some sort of advert, but just because it's really important that you measure your web performance from a real user perspective, because ultimately you cannot optimize what you aren't measuring. So whatever tool you choose to use, just please have one, is the takeaway there. So the reason why I joined Cloudflare, and specifically why I work on that product, is because I love the web. I think it's an incredible gift to the world. You know, we can write code once, deploy everywhere. We can reach a global audience literally within seconds. And if we want to change something, again, a couple of seconds. That's something that we should really take a moment to realize how fortunate we are, because even in tech, you know, other platforms do not have that because of gatekeeping and whatnot. And then look outside of our industry, you know, you can't just roll out a new version to a bridge or something. So we're very, very fortunate. But unfortunately, the web has a JavaScript problem. And for my entire career of now over 2 decades, basically it's always had one problem or another. The problem that I'm going to discuss today is the fact that it's growing faster than any other resource, if we look at it kind of percentage-wise. So I suppose in one respect, at a JavaScript conference, you can say, yes, we're winning, more JavaScript. But there are some problems with that. My colleague, Tim Kadlec, recently ran some numbers, and he was looking for like the greatest period over the past couple of years where JavaScript has kind of grown. And he found this period starting in May last year, where we saw a 15%, over the course of 10 months, a 15% increase on desktop and a 10% increase on mobile across the 75th and 90th percentile of our kind of largest websites. So the heaviest 25% and the heaviest 10% of websites got even heavier. And his theory is basically that LLMs are now accelerating this. So that's kind of where that bump came from. But you know, Phil talked to us about kind of the history of JavaScript. So if we look a little bit further back over the past decade, you can see that this hasn't just started happening now. It's been a continual increase. In fact, we've increased the volume of JavaScript basically across every percentile by a factor of 3. So a quarter of websites now serve over 1.5 megabytes of JavaScript, and 10% of them are over 2 megabytes. And that's the transferred size, the bit that goes over the network. That's not the uncompressed volume of JavaScript that runs actually on our devices. And there's a thing that's kind of perplexing me a little bit, like, is the web really getting that much more interactive? Like, what's happening? I asked an AI to kind of produce a list of like the web's hits, like what were the different kind of categories and the leaders in those categories that defined them or have stayed the test of time and we now take for granted every single day, across social media, e-commerce, etc. And if you look at the dates that these companies launched, these products launched, really these kind of happened over a decade ago, most of them. So these aren't unsolved UI problems that are completely new to us. Like even you look at AI, the kind of chat interfaces that we see on the web. It's like we've had chat for a very long time. So that's not really a new pattern, whilst obviously AI is very new to us. So you might be thinking, well, we're at a JavaScript conference. I should be here advocating for more JavaScript, not less, right? So why is this such a problem? Why are you so angry about it all? Why do I care so much? And the thing is that byte for byte, JavaScript is the heaviest resource we have on the web. If we look at something like HTML, this is parsed in a streaming fashion. So as it downloads into the browser can actually do things with the bytes that it receives. With JavaScript, that's not the same story. Effectively, we need the whole file to arrive before we can fully parse, compile, and execute it. So it's not kind of useful along the way. And then when it comes to things like our images and video and things like that, those can be shifted off to another thread. They can be GPU accelerated. A lot of laptops and phones even have hardware decoders specifically for certain formats, whereas the majority of JavaScript that gets written basically fights over a single thread on our CPU. So you can imagine what happens there. This is all then compounded by the fact that we love to bundle things together. We want to get our file sizes as small as possible, but there are trade-offs with that. Effectively, yes, we might get a smaller output and have a little less bandwidth here and there, but we might be sending JavaScript that we don't actually need. Again, that has to be downloaded, parsed, and compiled. This might be something that we don't necessarily need during page load. It might be something that we don't even need on that page, but our kind of bundling tools just abstract that away from us, and that's something that we need to be very cognizant of. And ultimately, this results in this kind of very frustrating period between a page becoming visible and then it actually becoming interactive. And Paul Lewis from Google attributed the phrase uncanny valley to this period. And some of you might be thinking, well, our devices are getting faster though, right? I do watch the Apple keynotes and the Google keynotes, and they tell me everything's getting way faster. If you actually look at this, yes, if you look purely at the benchmarks, if you have visitors who are all buying the latest flagship iPhone every single year, then maybe, as long as it's got full charge, it's got a really strong signal, it's on your gigabit Wi-Fi at home where you're uncontended and all that kind of stuff, and there's nothing else running on the device, then maybe we're keeping up with the increases here. But the interesting thing is, this is a chart from Alex Russell from Microsoft, and he says that I can't actually see the laser pointer, but these two categories down here, these represent 2/3 of new devices that are purchased at the moment. So 2/3 of devices perform worse, or at best, as well as an iPhone 8 from, again, almost a decade ago. So effectively, even if our visitors are baller enough to be buying these brand new flagship devices every single year, which is exceptionally unlikely, we're still at the whim of Worth's law, which explains that our software is growing to be more and more demanding faster than our hardware capabilities are growing. But I'm not here to outlaw JavaScript. I can imagine I probably wouldn't be invited back ever again if I did such a thing. And ultimately, the web will be a worse place if we didn't have all this interactivity and we weren't able to kind of, as developers, push where the web goes and show the browser implementers and the standards folks that, we want this feature. Look at things like jQuery. We don't need to use that anymore. But that largely led a lot of the browser APIs that we take for granted today. The thing really I want to kind of question is just the cost of our JavaScript. And the good news is that the platform is quietly fighting back. It always has been, but we just haven't been paying that much attention to it necessarily. So we've had things like HTTP2 that massively reduced the overhead of sending individual files down to the browser. We still have that kind of compression to think about, and that's something that I'll talk about in a moment. But the overhead, we can compress headers. So if you're sending the same headers down for all your images, for example, now we only need to really kind of send those once and then just reference them. So that took away a lot of that overhead. We've had things like Brotli come in, which gives you, at best, kind of like a 30% improvement over gzip. Some things it's more like 15%. That's kind of for free almost. We've had tools come in to kind of help us help the browser, things like fetch priority and resource hints, to try and give it a kind of lift along and show what resources it's going to need and when they're going to need to be downloaded. And then continually, HTML and CSS are kind of eating away at where we need to use JavaScript. And the great thing about this is that this platform knowledge is something that doesn't really go away, because once things are in the web platform, unlike, I think there's like the marquee element got ripped out at some point, and the blink element. They may have come back though, I'm not sure. But yeah, very few parts of the web platform actually get fully deprecated, and that knowledge becomes useless. Phil mentioned things like jQuery getting introduced, and I know many of you put your hand up to say, yes, I use jQuery. And I was thinking about this kind of quote from a lot of parents will say, really cherish the moments with your child, because at some point it'll be the last time you pick them up. And you won't know when that is. It's like, I can't remember when I last used jQuery, but there was a last time. That knowledge to me, it may come back round, but that jQuery knowledge is probably irrelevant, whereas web platform knowledge lives on. It's always going to be useful. So, looking more positively, let's look forward to a couple of APIs that are helping us today and more so in the future. So I talked about compression a little bit with things like Brotli, but this kind of regular format of compression can only take us so far. A colleague of mine, Alex, ran this experiment on this new technology. He found a 272 kilobyte, I think it was a JavaScript file, and compressed it with gzip and got it down to just under 100 kilobytes. He didn't actually test Brotli, but I've applied like the 30% best case to this to get it down to kind of 64. And then this new technology lets you get it down to just a couple of kilobytes. In fact, these numbers are so impressive that you know how with things like gzip and Brotli, you can set like a level of compression, like how much CPU time do you want to burn to get it as small as possible? And you're chopping away those last few kilobytes. That largely becomes irrelevant, because you can just do it at a very low level, keep it as fast as possible, because this has such an impact. And the benefit of that is that you can do this with dynamic content. So whereas with Brotli, typically that's reserved for our static assets, this can be used across everything. It's not just the bandwidth that we save on as well. The latency actually improves as well, because, of course, as we're transferring these files, because they're having to go across the network, maybe from your origin to a CDN and onto a customer, that transfer gets faster across that network as well. And then, of course, the download is so much smaller, you're getting down to literally like 1 millisecond. And he's produced like more of a visual demo at canIcompress.com. So if you use Chromium browser, you can experience this, and as you can see, basically every minute this rebuilds with a new graphic, and it reports how much it had to download for that new page. And we can see it's measured in, the screen's maybe not high enough resolution, but it's like 400 bytes for a whole new visualization. So before I show you what this technology is, you've got to promise that you're not going to do bad things with it. Because you need to remember that whilst this will compress the JavaScript going over the wire, it's not actually going to change the runtime execution of that JavaScript. So if you see this as great, I can compress my JavaScript down to 1% of its original size. That means I can use 100 times more. All you are is going to like shovel more JavaScript down the network and then increase that likelihood of bottlenecking that single thread that we use. So basically, I don't want to see this happening. The whole point is that we should get smaller rather than greater from here. So what is this new technology? It's called compression dictionary transport. Sounds very technical, but I'll explain. It was introduced as an IETF proposed standard back in September, so it's been through a lot of rigor to get to that point. It's very, very stable as a specification. And effectively what it does is it allows you to use the contents of a resource that's already been downloaded to compress something else. So before, where we could only compress within a given file, now we can compress across files as well. And why you might want to do this is, for example, if you're rolling out a new release, you might have got the best caching headers on there. So, those files live in the browser for as long as the visitor needs them. But if you roll out a new release, they're going to have to re-download the latest version of all your JavaScript files. And you pay a penalty for that. They're having to re-download that whole file, even with Brotli, whatever it might be, hundreds of kilobytes. But now we can ship just the diff. Like if you imagine literally like a GitHub diff, those kinds of visualizations, that's the bit that we're sending down. And even that, then we compress again. So it's really, really powerful. It can look for those that repetition across those different resources. And effectively, this means that we can get this really symbiotic setup where we can get the best of both worlds. Rather than having to bundle all these files up together and kind of trying to optimize for the the smallest file size. We can now spread them back out, still get that small file size, but we get the benefit of that kind of granularity in our cache. So if we change just one file, only that tiny bit changes, and we don't have, we're not re-downloading all these different bundles. And how you do this is literally just some HTTP headers and a little elbow grease to apply the actual compression on the server side. I actually implemented this on my own blog, and I wrote up a big blog post on how to do that. It can be a little tricky because some of the compression libraries don't support dictionaries yet, but that is very much moving forward very, very quickly. So this is something that Shopify have actually put into production. So this is Shopify checkout. If you look at the JavaScript, you can see that they're all fingerprinted, so that's effectively the version number in the actual file name, and you can see they've got this user's dictionary header. Within there, it tells the browser, use this as a dictionary for anything matching basically the same file name, but any hash. So version 2, version 3, version 4, etc. can use this old version to upgrade. So let's dive into a little bit how this works. So say you're brand new to this website. You request version 1 of some JavaScript, and the server says, well, you didn't have a dictionary yet, so I need to send you the whole file. So what it'll do is it'll send the file back, but it will also say, hey, you can use this for future versions. And then your browser, once it's used that file, it will also store it as a dictionary in its cache. And then just say you roll out a release, and then people browse to another page. HTML says, yep, there's a new hash on this, so you need to go away and get that file. And the browser, instead of just saying, hey, give me the new file, it says, I've got the old version, here's the hash of it, so it can make sure that its contents match and nothing's gone awry there. And it says, hey, give me the dictionary version. The server will obviously have to look up that old version, so you need some kind of persistence across these versions. You need to keep a track or a cache of these old build artifacts. It'll look that up, it'll recompress the response with that dictionary, and then ship it down with just a few bytes back to the browser. And then the browser can take that few bytes and kind of explode it back into the full file. There is one caveat to doing this, which is you need to have stable bundles. So if you've got all these modules in your files, when you do a release, you need them to stay in the same groups with your output. If they're all moving around like this each time you deploy, then of course there's going to be a bigger diff effectively, and you're going to minimize the kind of effect that compression dictionaries can have on this. As far as I'm aware, Vite does support this and does do this. I don't know whether it's a default or an option. I'm pretty sure it's the default. So yeah, you need to pay attention to what you're outputting with your builds. There's another format of compression dictionaries that Google are using. So they actually serve a standalone dictionary. You can see there's a special request that's fired off. And they use that to match basically everything. It's just like anything on the slash and beyond. And they can use this to actually compress the results page. So you view Google, you start typing in your query, and then that results page is as small as possible. Obviously, they're operating at a level where the odd byte makes millions in difference. And one of the big things that they used to do is their logo used to be a standalone file. So they download like an SVG or something like that. And that was, again, a trade-off because they wanted to be able to cache that, not have to retransmit it all the time on every single page, if you were to embed it. But at the same time, it was more round trips. It meant that logo took a little longer to come in on some slower connections. Now they've been able to just embed it directly in the HTML. So that's what is enabled for them. And you can see in the response, we get this content encoding type of DCB. So DCB stands for Dictionary Compressed Brotli, and then you have DCZ for Dictionary Compressed Z Standard. So I implemented this on my personal site. So if you go to my homepage and then navigate to any page, this is the events page. In Firefox that doesn't support compression dictionaries yet, I get a 21 kilobyte file. Pretty good compression ratio of 85%. It's a lot of inline CSS and stuff like that, so it compresses pretty well. But if I do the same thing with Chrome, I get 5 kilobytes. Yeah, it's not bytes, but there's a lot of unique content to this page, so that's probably why. And this is still 4 times a quarter of the size. And actually, if we compare that to HackerNews, which is famously minimal, it's about as minimal as you can get. Even if you look at the HTML, it's basically just like a bunch of spans. That's 6.3 kilobytes, so I'm beating HackerNews at this point. And the way that, if you want to implement this yourself, basically what you need to do is kind of look at the common elements across different pages on your website. So you might go, okay, this is an e-commerce site, but our kind of header and the mega nav is the same across all of these. And there's a bit that you can't even see visually. The head tags of your pages, most are going to be in the similar format. Some of the meta tags might change the content, but where they are in that head tag will probably be the same. There's going to be a lot of repetition in those, so we can bring all of that into our dictionary. You can literally just create a text file. You can do this manually, so if you just want to trial it, you don't have to have some complicated build system, although the Brotli and Z standard libraries do have a solution on the command line where you can train a dictionary by giving it a load of files, and it will figure out what's unique, what's common to them all. The only thing you've got to watch out for there is that you don't have any personal user info in there. And yeah, when you kind of look at these standalone dictionaries in this format, to me, it resembles what we've done with single-page apps. So it's like we've got this shell. We're just going to send down the shell because that's the same across all of the app. And then when we navigate, we're just going to fetch some JSON, and then our JavaScript's going to compile that and render that into the HTML that becomes our page. Whereas with compression dictionaries, we just make that our dictionary, load that standalone. It will load out of band, so just when the browser's idle and not really doing anything else. And then when you navigate, it will just load the diff of that HTML versus the page, and you get your new page. And the browser does all of that for us, so there's no JavaScript involved at all. And like I said, it's just a text file. You can put a link tag in to reference it. The browser will take care of downloading it and all that kind of good stuff. And you just need one header. So you can match on the URLs as the previous examples, or you can say, I want to use this for a particular type of file. So style sheets, JavaScript, documents is your HTML, all the usual kind of, you might have seen these from things like CSPs. So when can you use this? It's already in Chrome. And I believe Firefox is pretty much done. I saw last night that they put in the ticket in Bugzilla to say, let's release this. So it's going out to, I think, the beta version, and then they've got a progressive rollout to stable. So it's already basically done. And Safari, I've just seen, have just started working on this as well. So they've started pulling in the tests to actually implement it. But the point here is that you have to have the fallback anyway, because some people are new to your website. They've not already downloaded this JavaScript or your dictionary effectively. So you're going to have the fallback anyway. So you might as well implement this as a progressive enhancement, because you can actually impact over half of web users today, the Chromium bunch. So there's no real reason to not implement this. And if you're interested in our plans at Cloudflare, what we're going to be doing with this, again, my colleague Alex has written up a long blog post all about them, so feel free to go and read that. Now, obviously, being faster than HackerNews is pretty fast, but I did say the fastest. So how can we beat something like, if you had a React app that didn't even need to make a network request, is there anything we can do to beat that updating the DOM? And there is actually something. You may have come across these. They've been around for a couple of years now, but not seen enormous adoption yet. But it's a really powerful feature that works hand in hand with the compression dictionaries. These are speculation rules. We rolled out a feature within Cloudflare that when people enabled for successful prefetches, we saw their LCP, so the metric that we use to measure load times from the user's perspective, reduced by 45%, so staggering improvement. And what they are basically is a declarative API where you can specify what pages you would like to either be prefetched, so just download the HTML, or completely pre-rendered. So this is effectively like opening a background tab and then just switching to it. And the reason we might want to do this is that this actually hides any latency. So we can't eliminate the network request when you're navigating. Something has to happen, but we can do it beforehand and try and get as accurate as doing that. You might have come across libraries like Instant Page and things like that that try to do this with JavaScript. And how we do this within the web platform is literally just a tiny blob of JSON. This blob of JSON. So this is pre-rendering. So you set the version that you want at the top, so pre-render or prefetch, and then you give it a bunch of rules. These can match on URLs. You can negate those as well, so you can say never prefetch this or never pre-render this. And also you can use CSS selectors as well. So if you have weird and wonderful URLs and you've got no real sense of pattern there, then you can just match it all on CSS if you want as well. And there's an eagerness option there that I'll come to in a second. So this is really cool because there's a few benefits to this being in like browser land. The browser can know things about our user that are privacy concerns that we don't get exposed in the APIs. So it might be things like the memory availability or the pressure on memory. I know there are APIs in Chrome for that, but the other browsers don't really like to give that away. So they can implement this safely and adapt to that. So they go, oh, we've not got a lot of memory. You know what? We're not going to pre-render the next page because we don't want to have performance take a hit. It could also be things like someone's got save data mode on, so we don't want to go prefetching loads of stuff ahead of time. We're just going to wait for them to hit that link and really conserve bandwidth. So I've implemented this on my personal site. There's actually a DevTools panel for this. So you can see we get these little green pills when it's successful. This is throttled to a slow 4G connection. So you saw a bit of progressive kind of download there when it first loaded. But when I navigate to the pages, it is just instant. There is a bit of animation there because I've got view transitions in as well. But you do get absolutely instant page loads. And you can see that with the little green pills, as I say. So like I said, the way that the pre-rendering works is you can imagine there being like two tabs. And effectively, one's hidden. So our next page, page number 2, is hidden behind page number 1. And then when the user clicks the link or submits the form, we just flip the two. Simple as that. It's as fast as it possibly can be. My friend Barry Pollard from Google said this is the only way you can get faster than client-side rendering, without making any fetch calls, because it literally is as fast as the browser can render a frame. So we're talking less than 60 milliseconds or something. The only trouble with pre-rendering is that it can be quite wasteful. It's expensive to go away and download a whole page if someone doesn't actually go and activate that. So we've got to work around that. And then also, our JavaScript executes. So, your analytics tools, if they've not adopted this new technology and they don't cater for it, are suddenly going to report an explosion in the number of page views in their systems. So we can mitigate these in a few ways. I mentioned the eagerness level. So you can set this to 4 different levels. And again, the browser's always working to kind of refine these, get them as accurate as possible. And I know that this is taking away a little bit of control. I remember the days when lazy loading first came in, like native, the loading equals lazy attribute. And a lot of people were like, no, I want to control how far below the viewport when they load in and things like that. And browsers, it took them a little time to kind of refine, and we're in a good place now where it's pretty accurate. It does it kind of just in time. So these are our first kind of layer of defense. You can obviously be more conservative at the top. You can wait for someone literally to tap the screen or press down on their keyboard, or on their mouse rather, and wait for that to happen, and literally just use the latency between them pressing down and lifting their finger off. That might be a few hundred milliseconds, and that might be enough. If you use compression dictionaries, that might be enough to actually load all that HTML. Obviously, you can get kind of more eager with this, all the way down to like immediate, which is like, as soon as the browser's idle, start downloading this stuff. But the more interesting ones are kind of in the middle. We've got moderate, which is fairly straightforward on desktop, waits for you hovering a link for 200 milliseconds and then kicks off the process. But on mobile, they're starting to do fancy things like figuring out, as you're scrolling, where your finger was and what element is nearest to where your finger was. Again, these things will get refined over time, and you don't have to worry about them. And then you can combine these options with whether you pre-render or prefetch, which I've already described, but there is a third option coming. This is currently kind of being trialed by Google Chrome, and this is pre-render until script, which literally does what it says on the tin. This will start pre-rendering the whole page, but as soon as it sees that script tag, it's going to stop. So none of the JavaScript executes. You don't have to worry about your analytics. You don't have to worry about other API calls firing off and things like that. So you can do that with, maybe you don't need to be quite as kind of concerned about being accurate about that. And if we look at some of the successes from this, Shopify have implemented it, and they use the most conservative approach, conservative eagerness and only prefetch, the least impactful combination. But even with this constraint, they saw improved loading metrics across every percentile. Desktop, 130 milliseconds, 180 milliseconds on mobile. And then last Monday, they just reported that they've stepped it up from conservative to moderate, and they've seen an additional 200 millisecond improvement on all the metrics at the median level. Mobile is kind of less impacted, but that's probably because of those weird heuristics around where someone's finger is. But the amazing thing to note with this, and these charts are very small, so I apologize about that, but at the median on desktop, almost at the median, almost half of people get a 0 time to first byte. So that means half of people are experiencing page loads where the HTML is already loaded. So all it needs to go is download any additional assets, which is incredible. They're basically getting an instant experience. And while these metrics are super positive, one thing that they don't show is that waste. So, if you get things wrong, you might be wasting people's bandwidth, you might be wasting your server processing, your infrastructure to build these pages. And that's why Yoav, who worked on both of these APIs, has now proposed a special measurement API. This is in Chrome Canary only at the moment, but this allows us to measure whether or not these were successful. So remember, you can't optimize what you aren't measuring. So when can we use these? As I say, pre-render until script is just kind of experimental at this stage. Prefetch and pre-render, again, are in Chrome already. This is a progressive enhancement. Feel free to use it today. Safari and Firefox are both working on prefetch because that's the kind of safest option. I think there was some concerns over the complexity of doing pre-render from Firefox, I believe. But Safari does already, as you're typing, it is doing a pre-render of the page of the websites that it's predicting you're going to go to. So they already have the mechanism, so hopefully it's not going to be too difficult for them to do that. And again, if you're interested in how we apply this stuff in one of our products, you can read all about that on Alex's launch post. So just to kind of wrap things up, compression dictionaries reduce our network overheads. And we can combine these with speculation rules to hide that latency. By combining them, we get this extra effect of needing to be kind of less worried about our accuracy because, like with my personal site example, I was using a quarter of the bandwidth. So that meant that effectively I could prefetch 4 times the volume for the same cost. And this is what I love about the web, is when you start to think about all these different web platform APIs, they're great in isolation, and they're great for you to kind of progressively adopt and go, you know what, I'm not going to chuck away this massive project, we're not going to migrate to a whole new tool, we're not going to rip everything out and use web components, that would just be a lot. But we can start to chip away at it, and then they start to compound together. I didn't include it today, but I did have a section on view transitions, but Sid's going to be talking about that later. And again, these have this kind of compounding effect of you get that kind of app-like feel with view transitions. And then the great thing is that you don't have to have a whole bunch of JavaScript to do that. So again, that feeds back to the speculation rules. It means that they're going to load quicker, and you're going to get more instant page loads. So my entire career, JavaScript has been a problem. And over the past decade, we've doubled down or tripled down on the thing that's kind of hurting us. But when you start monitoring, you'll start to see that the LLMs aren't really saving us from worse law. They're kind of turbocharging it. But the platform is there giving us the tools to do better. So please lean into it. Understand the raw materials that you're working with, HTTP, HTML, CSS, JavaScript, not because it's like tidy or like virtuous, but because the real users of your websites, of your web applications, using the devices that you're not testing on in countries that you're not really thinking about, they're the ones that pay the price when you don't.